So I had a chance to test some of these large capacitors, 400 volt, 4300 microfarad. This guy right here almost blew up really bad, basically swelled up and cracked, and there was an internal pop that sounded like a muffled pop, but it really wasn't like a massive explosion. Pulled a little piece off there. You kind of see down in there, it's just huge fruit roll up, but it's all dried up. Pretty bad condition, obviously. The thing is, you know, when you measure the capacitance on here, it's going to read about 4300 microfarad, right? So I'm basically just going to sit that sucker in there like that, close this thing while I charge it. Here's my setup. I've got the capacitor in this box over there. I've got it covered up because I'm not trying to advertise Makita. Here's the leakage tester I ended up boxing up. I also forgot to mention that I had a 500 milliamp label on this bypass switch here, which I don't know why I put that there, because it's actually 5 amps, and I just never changed the label, and I just fixed it now. But just kind of show that, short the output out, bring that up to about an amp, a little bit over an amp. You can see it reads close to about an amp. So, but yeah, I didn't calculate that very precisely, but the wire that I had cut for it just happened to be right about what I needed, about like a 0.14 ohm, something like that. When you see that needle swinging up, you know, on that bypass button, that means you're really pushing some current. Now on the 50 milliamp scale, got full deflection, so about 50, it says about 51 milliamps, but so it's about accurate. And about 24. When I get down to that 1 milliamp, then it's fairly close. It's reading more like 2, right? So anyway, that's close enough. Okay, so it's holding 60. Went up, shot back down. See what happens when I put it on the 50 milliamp scale. So already at that low voltage, that thing is doing all types of wibbly wobbly. So it's kind of bumping up into like 10 milliamp bumps. Not real sure what those bumps are. I don't know if that's just the actual frequency of the ripple doing that much damage. I wasn't expecting it to really get that high. I really don't want that shit to pop. So that right there, clearly, you can see clearly is a bad capacitor. I mean, I haven't even gotten up to 150. There's really no point trying to see what the leakage is. I already know it's no good. So maybe at this point, I'm just gonna keep bringing it up. Surprised it ain't pop. Oh, feel like it kind of wanted to. You see what's happening? Look how much that thing's leaking now. That thing was leaking a whole lot. So you see what it's leaking? At that point, the ZVS was working real hard, so I backed it down. So basically, the capacitor is wanting to fail up at that voltage when it starts leaking that bad. I'm not going to pop it. I didn't really want it to pop, and it already has popped once initially. Then it popped again once I brought it up to, I think, maybe 150. Popped real loud. That's why, obviously, why I put it in this box. I wouldn't even want it to pop, you know, in the box at like 200 volts. So I'm glad it didn't, but I got this clear indication that that shit is no good, right? And here's a more common capacitor. It's a smaller guy. It's pretty old, kind of beat up. 450 volt. 100 microfarad. That's it. So I'm not too worried about that guy popping in any kind of way. It's at 62. Start bringing it up. I can actually do that on the 5 milliamp scale because it's not very leaky, doesn't have any problems, at least yet. So 450, I'm just go ahead and, whoop, it's getting a little harder on it. Let's keep going up. So struggling a little bit. Put it back on the 50. Bring it to about that point. So it's actually it's reforming a little bit. Go ahead and bring it to like bring it 400. Okay, so now you can see a little under its rated voltage. Needs to reform. So I'm guessing if I let that sit there and go down, once it's finally gone all the way down, I could discharge it and then go through that same process, bring it back up to the same voltage, and it's not going to have to sit there and slowly reform all the way down from like a 2 milliamp leakage or so. Alright, I let it sit there for a while, and now it looks like it's finally going down to about 100 microamps or so. So I'm going to put it back up on the 50 milliamp scale, keep bringing it up. Just going to go ahead and bring it to about 450. So that's about its rated voltage or so. We'll back it back down a little bit under. Put it back on the 5. I'm going to let it reform again. So now I'm just going to let it sit there for a little while. That's about reformed, I guess you could say, as much as it's going to reform, right? So basically what I'm going to do now is just cut the supply off, right? Let it drain down. I'm going to discharge it, right? So now that it's discharged, I'm going to actually just go ahead and let it discharge down for a while. Then I'm just going to cut the supply back on and bring it back up to the same voltage and then see what it does immediately. If it immediately wants to sit at about 2 milliamps or higher and then kind of slowly go back down like it did, where it actually took, over several minutes, something 5 to 10 minutes to actually settle down, then I know something's wrong with this guy. If it doesn't, then it seems like successful, reforming, right? So that's about good. Take the bleeder off, and I'm just gonna cut the supply back on at the same voltage it was at. And boom, take that off, back on the 5 milliamp scale. So we're already back down pretty low. Let's see how long it takes. So it's already back down to about, the point where it was, right? So it didn't go through this whole process that it had to go through before. So I guess you could say that right there is a pretty good example of reforming, to where you might want to take it easy, because if I didn't take it easy and I initially just slammed this 448 on it after just pulling it out the box for however many years it was sitting there, instead of seeing the leakage that I saw, probably would have been way off the scale and potentially damaging